Harry, welcome to the Leanpub launch video for the Architect's Paradox, Uncertainty and the Philosophy of Software Architecture. I was wondering if you could take a moment just to talk a little bit about yourself and who you are and your background and what your book is about and who it's for.
Yeah, thanks, Len. So I'm a software architect, 25 years in the business, was a chief architect at Microsoft at one time. Since I've left Microsoft, I've been working on a PhD in complexity science and software engineering. And last year I released a book on Leanpub called Residues, which has done quite well, on how we can bring the complexity sciences into software architecture and change the way we do things. And the Architect's Paradox is kind of a prequel to Residues that talks about the philosophical background of software architecture, why we think the way we think, in the hope that once we become aware of that, we can tweak it slightly and think new thoughts and be able to think about architecture in a different way, that maybe gives us a new way of thinking as we move into the future where software architecture as a practice is kind of questioned.
Yeah, and in particular, the book is sort of directed at people who are maybe sort of programmers, people who've done lots of software architecture and things like that, but don't necessarily have a background in having read too much philosophy,
Yes.
let alone the history of philosophy. And so you tell these sort of parallel stories about the history, the way philosophy has changed over time and the way sort of the philosophy of software engineering has changed over time.
Yeah, and that's so a big one of the things we realized as I was writing the book was that it's not just a prequel. It's not just the part of the story that I've been putting together. It turns out that this is a really cool way to introduce software engineers and tech people to philosophy, because we talk about all the major thinkers. We cover 2,500 years of philosophy, but every idea, every thinker is related back to technology, to tech, the impact that it has on technology, and also helping us to realize that, we think we're these cool, hip people on the cutting edge, but the same discussions that we're having today were had by two guys in a square in Athens 2,500 years ago. So, and there is a parallel, which I've drawn and maybe exaggerated a little bit to make it to make it more fun, between the development of philosophy across in the West across 2,500 years, and the way that software architecture has developed over the last 70. With these sort of initial attempts to keep everything still, to keep everything simple, and then moving into a phase of chaos and despair and meaninglessness and why are we even here, and gnashing of teeth and all of that, and then eventually accepting that everything is moving all the time. We can't hold it still. What if we just went with that? What would life look like? And so this mirrors the development of the software industry in the history of software engineering. Sometimes you have to squint a little bit to make that fit, but
It's
it's
so interesting too. There's the software engineering, there's philosophy, and there's the self that the journey that we all have to go through. I mean, we're all born knowing the same philosophy, which is none,
yeah.
or in a sense, we go through this process ourselves, and it's sort of interesting how like the ordinary human experience in whatever profession is kind of recreating these contradictions and sort of controversies just in ourselves. So, for example, one of the sort of at the heart of your book is the idea that some of us have a desire for certainty and logic, what you also call stillness, to exist in the world, and then we might develop our ideas around that world forming intuition about the world rather than actually like seeing the world for as it is.
Yes, exactly. And that's something that can be a part of a personality. There's certain personality types who want to keep everything still and have order and control. But it very much comes from our computer science educations as well, because they don't teach us anything else. They only teach us how to keep things, how to grab it, how to grab that conceptual model, hold it still, and map it to code. And that's very much, if you lean that way, and then a computer science education will definitely encourage that way of thinking, way of seeing the world. This search for stillness, in the chaos of a business, is the same thing that leads to crumbling architectures, also leads to waterfall ideas and processes. Then you have to have an agile movement that tries to set fire to everything to get people to realize that this is not how it actually works in reality.
And it's interesting, the sort of the nature of the paradox, the software architect's paradox, is that we wouldn't have computing as it is if it weren't for going through that journey of logic in the first
Yeah.
place.
Yeah, and that's something I think that came out of the writing of the book and the title as well, is that you can't get to computing without reducing everything to pure logic, and that logic has to be solid for the computer to work. And then once you move beyond that and try to build computer systems for large organizations, which are anything but logical, then everything crumbles because you only have that one tool set. And that's what the architect's paradox is. So the skills that got us here are the same skills that are going to cause us to repeatedly fail as we try to build systems for human systems. And that's something that once we're made aware of it, is possibly something we can fix, something we can move away from.
Yeah, and speaking of fixing things, so one of the really interesting things about your book is the way it ties these sort of like, high theoretical things, both in history of philosophy, the nature of software engineering, into very practical problems in the world. And for example, this line I've got, 4 stars next to it. And I'm just gonna quote you back at yourself. But the use of specifications tied to legal contracts protected us from the inability of software architecture to constantly deliver. The business model this created was enviable. When we failed to deliver something, the customer got to take the blame and pay us again to build it a second time. End quote. Um, and one of the reasons I love that line so much is because it ties the sort of nature of programming and the nature of the business world together to explain why we constantly encounter these huge failures in sort of software projects. And this goes, it's not just, the last 5, 10 years. It's not just the last 20 years. It goes back, to the beginning, including very in particular sort of, observations about this around 1968. So I was wondering if you could talk just a little bit about that, about like how this sort of the nature of this problem of sort of business and computing.
Yeah, so it was always there from the beginning. Doing business, or building a business or working in the business world is very pragmatic, very human activity. And as we got to, because it was people like Frederick Taylor who started to try and make business into a scientific thing, same kind of thought that existed in software. And so software builds on the logic of people like Frege at the turn of the century, Bertrand Russell, Ludwig Wittgenstein, who I think most people would recognize that name, try to build this world centered on logic. And it starts to fall apart very quickly. Already in the 1960s, we're still sort of in the beginning of building business systems. And so 68, everyone gets together. Um, Dijkstra, Hore, all the big names in Garmisch in Germany. And they say, why do we suck at this? Why does it keep happening? Why don't we deliver? Why is it never on time? And even when it is on time, why does it not work properly? Why can't we deliver to a specification? And the conclusion there wasn't the conclusion my book reaches is that everything is moving, everything is changing all the time, and we just can't keep up, and that's the nature of the beast. They said the reason that the reason this keeps happening is because we're just not good enough at engineering. And we're looking at our engineering cousins in mechanical engineering and electronic engineering, structural engineering, and we're thinking, why can they do what we can't? Why can they deliver in time? Why can they deliver? Why can their systems stand up the way they're supposed to stand up? Why can't we be more like them? And the decision was taken in 68 to become more like engineers. And I call this the engineering paradigm, where we decided to mimic their behaviors, mimic their tools, bring in their ideas. And we tried to freeze everything and make it still. And we used all kinds of tricks from around language, things like requirements engineering, and risk management. And we tried to make our world resemble their world in the hope that our outputs would resemble their outputs. And that made everything stiff and structured, and it made it all sound. They made a story that sounded very rational and very mathematical and very scientific, and we all fell for it. And we all thought, yes, we should do this. And then when we fail, we punish ourselves and say, well, we're just not good enough at engineering. And then we looked for as many patches and hacks as we could find, and the most effective patch was the contract. And so the problems were always in the gap between what a rigid analysis can produce and what actually exists in a business environment. We always have to reduce it down to something that isn't real in order to make it static. And when a gap turns up, that's the flaw, I argue, in our thinking. That's the paradox. But when that gap turned up, we were able to blame it on our customers and say, look, the reason that the reduction doesn't map to reality is because you don't know your own reality and you couldn't tell us what it is. So it's your fault. And we made our customers feel bad instead of ourselves. And that's genius. That's made us a lot of money. And then, of course, Steve Jobs comes along and has a whole different perspective. So the user is at the center. The user, we have to think about them and their experience of the software, and that's tilted things. We started to think a little bit differently. And if you bring that to an enterprise level, at some point we start to think that maybe we should stop blaming our customers and realize that there is a journey that we're on. And there are a lot of senior architects out there in the world who took this to heart and realized that I can work with my customers in conditions of high uncertainty. I can get rid of this contract, this requirements, this idea that there's something rigid, and be honest with the customer and say, there is no rigidity. We don't know where we're going. This isn't going to be nice and orderly. This is going to hurt the whole time we're doing it. But if we're honest about it, we'll get a result, the best result we can. And so when architecture became agile in the proper sense of the word, then we started to solve the problem. And once people started doing that, that causes a problem for everyone else who wants to be rigid, because suddenly they're questioned. And that leads to developers throwing architects out of the room very often and saying that we don't need this lines and boxes because we know they don't help. And that's where we have to now change our thinking industry wide.
Yeah, there's a very deep kind of very human sort of problem with proposing the kind of thing you're proposing, the kind of mind shift. And so one way I have it explaining is there's a certain kind of person who's, in the quest of a four-sided triangle. And if you say there's no such thing, the world isn't like that, they'll say, "Oh no, you just want to give up. You're just giving
Yeah.
up." And it's like, we're not giving up. We're telling you the world just doesn't work that way. But then this is a very deep problem because the person, as you sort of jokingly put in your book, who strides into the room and confidently sort of tells people what they want to hear, which is that if we just work hard enough, we'll get to a deterministic, clear understanding of what our requirements are. They're going to believe that. That's what they want. And you have a great line in your book where you say, to bring this down, like, not just to the sort of people making the business decisions, but also the sort of programmers building things. They have the sort of same idea, which is, this is just quoting you back at yourself again. The first instinct of the programmer is to try and describe the world in a familiar way by making the real world resemble the world of the computer.
Yes.
That's a very, very sort of funny, but sort of very deep and universal kind of insight into the way a lot of people who maybe come out of computer science programs think.
Yes, absolutely. And no one's really aware of it. And I guess I did it too when I came out blinking into the real world. And until it's pointed out to you, you've no clue that that's there. Once it's pointed out, it's shocking. And there's two reactions to that. One is to say, "Wow, that's amazing. I'm going to rethink how I look at these." And the other is to pick up your chair and throw it at the presenter because you've just had the rug pulled out from under you. And so I actually gone back on the advice of some of the early reviewers and rewritten some sections to make that blow a little bit softer for software engineers because it's kind of shocking, I think, to have this pointed out. Um, One of the first times I talked about this in public, the person who followed me on stage was a computer science professor, and he was just like, "Whoa, no one's ever said that before." And they said that. I don't know how to respond to that.
Yeah, well, there's something very deep about the moment you begin to reflect for the first time in your life. And as you say, there can be two reactions to that. They killed Socrates, right?
Yeah, yeah,
There's those of us who are into philosophy think the origin of sort of Western kind of thought was maybe Socrates, but it might have been the killing of him that was the origin of Western. Who won that battle in a sense. And yeah, when people are thrown onto their own lack of prior self reflection, Some of us go, oh my God, what an amazing revelation. I can't believe it took me this long to get here. And other people just want to shut the door. And I don't say that in a patronizing or dismissive way. Like
Yeah.
you just don't want to face that you've not been reflecting on things, that although you've been sort of proceeding with like, let's come up with ideas, but not reflecting on how do I create ideas in the first place? Maybe I'm in a context with a history behind it, and that there's a lot of formation going on before I get to the point of putting together ideas that I just am not aware of.
Yeah, exactly. And that's a tough discussion. I find that people who've been around in the industry for a long time, who've learned how to survive in this world, once it's explained to them, they'll say, "Yes, this makes perfect sense." Unless they're selling a framework or something that gets caught up in these philosophies of stillness, in which case it's a bit more difficult. Um, and very junior developers won't have experienced these problems for this to make sense to them yet. One of the things that I found really shocking was when I started talking about this, I first started at architecture events. So you're talking about people with 15, 20 years experience. And then one day, just for giggles, I did it at a developer conference, so much, much younger audience, much less experienced. I was kind of shocked that it was so well received. And then in June last year, I did it at a big developer conference in Scandinavia. And I thought, hey, they'll put me in a room somewhere at the back. There'll be four people who'll turn up who are interested in philosophy. It'll just be chilled. And they put me in the biggest room. And I got there. I thought this is going to be really embarrassing. There's 400 seats. There's going to be four people. And 15 minutes before the talk, there were four people. I thought this is going to be awful. And by the time we started, the room was full. There was 400 people sitting. There were people in the aisles, people at the back. I thought I'm going to and this is not going to go well for me here because this is such a broad, deep topic, and these are developers who won't have any patience for it. But they absolutely loved it, except for three people, and um and so that event and the response I got from that talk was what made me realize that this should be published. As I said, the book was started out as a chapter in the first book and just blew out of all. It just got bigger than the book, and so it was put to the side. I thought this is people actually want to hear about this. They want to read about this, and that's how it started snowballing towards this project.
One question I wanted to ask you is when it comes to the sort of reception of these ideas, and maybe the sort of what you just brought up, that maybe there's might be more appetite for this kind of thing now than there maybe was in the past. Is everybody there? You can't have a podcast now without talking about AI. And
Yeah,
and one of the observations that people with a programming background often make when they engage with AI, as they all have at this point, is like we're used, and the concept of prompt engineering versus coding, right, is the idea that like we're used to deterministic systems. There's a programming language, there's a compiler, I type instructions, those instructions run. If those instructions are correct, I get to a deterministic outcome. Whereas interacting with AI isn't like that. And there seems to be a lot of kind of scales falling from the eyes, or dogmatic slumbers that are being woken up from, and
Mm.
things like that. Do you think that maybe it's going to take people from this background, this intellectual background, and again, I'm not dismissing it because it's a very thick and rich intellectual background. Is it maybe going to take encountering machines that act like people for people to accept that people are the way that people are?
Yeah, so there's two things there that are happening that I think are encouraging. The first one is that AI and all the discussion around AI is pushing people to, in the book, I describe myself as being a software engineer lost in the wrong part of the library. And in the last 2 years, I've seen that the focus on AI is pushing a lot of people over to that side of the library as well. There's a lot of questions being asked. So what is conscious? What does it mean to think? What does it mean? What is intelligence? And another on the other side of the coin, I've given a talk, a very skeptical AI talk, which I call unstable diffusion, where I talk about how we are absolutely terrible at knowing the future. And whenever something new turns up, we make all these projections about what's going to happen. And that's never what happens. Something completely different happens. And every wave of technology that we were told is going to result in this. accidentally results in something completely different. So in the 90s, we had this concept called service orientation in tech, which we thought was going to give us these plug and play architectures that were aligned with business processes. And it completely failed to give us that. But it did give us cloud by accident. We sort of accidentally discovered a new way to build huge data centers out of this. And what happened was we had an idea, we had a projection of the future, we got a complete sea change in how we thought about software architecture. Cloud was supposed to give us elasticity and resilience and all of these things. It didn't give us any of that. You still have to work really hard to get it. The accidental byproduct of cloud is AI because it gives us all this spare compute and storage to be able to do those things. And so what I'm saying is that there's a future that's projected for AI. It's nonsense, right? Those futures won't happen. Although a lot of people will make money out of pretending that they will.
Mhm.
Um, the What's going to happen is that our ideas about software architecture are going to change because we're going to see that the deterministic way of doing things, um, whilst it might feel right from that old engineering perspective, the machine learning way and this goes back to my first book, of randomly simulating things until something clicks is much, much more effective in a complex environment than trying to predict and design and be rigid. And so one of my hopes is that AI will encourage us to think in a slightly different way about the way machines work. So that would come back, absolutely agree with your point that we can see that the way AI achieves things is not by predicting or controlling. It's just by throwing a bunch of stuff at a wall and seeing what sticks, and training and testing rather than predicting and building. And that would be, I think, beneficial to the software architect. Absolutely.
Definitely, definitely. One thing I wanted to, before I let you go, one thing I definitely wanted to mention about this book is for philosophers listening. If you're interested in learning about computer science from a kind of theoretical perspective, the book works from that direction too. Uh,
Yes.
just to give people a kind of nugget from the book, again quoting you back at yourself. I love this line. Kant is guilty of the enterprise architecture mistake of assuming the existence of a generalizing top-down model, never realizing that individuals are perhaps creating representations in entirely different ways based on what they chose to have faith in. And this just like there's the nugget for the philosophers there that like enterprise architecture mistake made by Kant. What does that even mean? That's just a fascinating way of thinking about Kant. But this idea that people create representations in entirely different ways is just a very, very important observation about our world. And it goes back to what you were saying before about, I was taking a note kind of rudely, but like, why can't we be more like them? And it reminded me of, there was Husserl, the philosopher, had a great extended essay called Philosophy and the Crisis of the European Sciences about 100 years ago or so, I think, where he talked about how people in all these other areas of endeavor saw the success of the kind of science, what we now call the sciences, in sort of coming up with sort of like predictability models for the world. If I turn on the Bunsen burner at, with this amount of water in it, at this temperature and this, in this environment at this elevation, et cetera, I know exactly how long it's going to be before it starts boiling, to pick one example. And everybody else desperately wanted their field to have
Yeah.
that kind of success as well. But particularly when you're dealing with sort of, let's just say like complexity science, or like to mash all kinds of other things together, emergent things, you can't really do that kind of science because there's no identity between things that you need, like one type of atom and another instance of it elsewhere are exactly the same as each other, not only at that moment, but wherever they are in space and time. You need that for the kind of predictability that what we think of as the sciences can get you. And that just isn't the case for, say, the human mind. Um,
Yeah. Exactly. Or the business systems that, by extension, the social systems that we have to build software for, and that's the huge gap that has to be bridged, and that's what makes being a software architect so difficult because you've got to work in both of those worlds for the minute, in the deterministic world of software and the indeterministic world of humans. and bridging those two things without breaking yourself, or without becoming dogmatic one way or the other, is incredibly difficult. Yeah.
And that gets to the heart of what you're trying to do in your book on the architect's paradox, uncertainty in the philosophy of software architecture. I highly recommend it to anyone, both philosophers interested in software architecture and software architects interested in philosophy, and in engaging with this sort of, there's these parallel histories of thought that can learn from each other. And it's also just a very fun, very fun read. You're very explicit about there's no test at the end. You have a great analogy about how learning about, say, like, I mean, it's true of philosophy, but it can be true of any other thing. Like, it's like walking into your in-laws, family gathering for the first time. You don't know who anybody is, but over time you meet them again and again, and then you'll remember their names and like who doesn't like who and who does get along and things like that. So it's a really great book. I highly recommend it to anyone just interested in these areas. And thank you very much, Barry, for publishing it on Leanpub, and for taking the time to talk to me and to talk to all of us in this video.
Yeah. Cheers, Sam. Pleasure.